way. So that is the reason why. So while accessing your application like a Facebook or Instagram or any other big application, you won't get any issues while accessing the applications, right? Why? Because they followed a particular structure to manage the data. They follows the particular structure to follow manage the data. So that is the reason why data structures are important. Data structures are important. So now tell me, what is a data structure? The data structure is the concept of forming the data in a particular manner is called as data structure. Okay, so for that, implement the data structure. For that, implementing the data structures, so we have so and so many algorithms. We have so many algorithms. So what we need to do, we have to implement algorithms. So algorithms are different and programs are different. So what is the program? What is the program? The program may be a set of instruction. Yes or no? The program may be a set of instruction. So you can write anything to follow the, to perform the requirement. Suppose if I want to add the two numbers, if I want to add the two numbers, so I can write by taking a simple variables and I can perform the addition and I can print the values. You can write anything to fulfill the requirement. That is a program. You can write any statements, any number of statement, irrespective of the time and duration, time and space, time and space. You can write the program and you can complete the program. So that is comes under instructions called as program. Then what is an algorithm? The algorithm is finite set of instruction. The algorithm is finite set of instruction that are completed, that are completed with effectiveness, that are completed with effectiveness. So ఏం చేస్తాం మనము? Program will execute and algorithm will execute. So what is the difference between program and algorithm? So program may take any number of steps and program may take any amount of time and program may take any kind of environment. But when it comes to algorithm, everything can be measured. Everything can be measured. So based on the one single problem, based on single problem, so we can provide multiple solutions. We can provide multiple solutions. Among the solution, we have to evaluate. Among the solutions, we have to evaluate. So this evaluation and performance, based on the evaluation and performance, we will make a particular algorithm is best for our requirement. We will make a particular algorithm best for our requirement. So this is the main difference between program and algorithm. So what is the difference between program and algorithm? So without performance and without evaluation, program contains what? Set of instruction. And what algorithm contains? Same set of instruction. But instructions must be evaluated and instructions must be performance evaluation, performance based evaluation. Based on that performance evaluation only, so we can say that problem, this algorithm is best. That problem, the algorithm is best. So in a formal way, in a formal way, the algorithm is nothing but a well defined computational procedure. Algorithm is well defined computational procedure that takes some value or set of values as input, that takes some value or set of values are input and produce set of values are output. So produce set of values are output. So nothing but algorithm is a sequential computational statement. Right. Right, everybody. పోయింది. ఒకసారి రీస్టార్ట్ చేయి. రీస్టార్ట్. Voice of speaker, speaker of. Hello. Right. What we are discussing here? So we are discussing ADS, that is nothing but advanced data structures and algorithm analysis. So we are talking about programming and algorithm. So what is the major difference between program and algorithm is? So program can be called as a set of instruction. So whereas algorithm is called as a well-defined computational procedure. A well-defined computational procedure that takes some of the values are input and that will give some of the values are output. Okay, so in middle of the input and output, so it will process the steps, it will process the steps. So we'll discuss what is algorithm exactly, right? So as of now, just remember, the algorithm is a well defined computational procedure that takes some values or set of values or input and produces the output. So this algorithm this algorithm so will have, every algorithm will have this criteria. So what are the criteria? The first one is input, the first one is input, the second one is output, the second one is output. So what are inputs? So whatever the requirement, suppose if I want to add two addition numbers, right? If I want to add two addition numbers, for adding the two numbers, what are the inputs I need to give? I need to give the values or variables. So that comes under the input and output. So at least one quantity is produced. At least one quantity is produced. So we are looking for? So we are looking for adding the two numbers. So the two numbers, sum of the two numbers is the output. So that output must be at least one or more. Okay, so that comes under output. And definiteness. Definiteness. What the definiteness means? So every instructions in the algorithm. So already I told you that. So algorithm is nothing but a computational step-by-step procedure. A computational step-by-step procedure. So each and every instruction must be clear and ambiguous and ambiguous. So whatever the statements you are going to write inside the algorithm, so every statement should be understandable, every statement should be understandable and manageable. And finiteness. What is the meaning of finiteness? So algorithm contains set of instructions that all the instructions must and should be executed. All the instruction must and should be executed. And the finally is effectiveness. So how the algorithm is better when compared to the another algorithms? So that is nothing but effectiveness. So when compared to all other algorithm, so this algorithm is better, so that comes under effectiveness. So now algorithm is nothing but a set of a finite computational instruction that takes a set of values or input and produces the output. Algorithm definition is clear or not? So what is the definition of algorithm? Nagaraj. Specification. Software. Associate. Software employees. Associate professor. Software employees this associate professor. BVRI. BVRI. right? So this is algorithm, and these are the criteria of every algorithm. These are the criteria of every algorithm. So every algorithm contains input, output, definiteness and finiteness as well as effectiveness. So these are the most important for each and every algorithms. It must contains each and every algorithm. So next, algorithm specification. Algorithm specification. You can specify the algorithm in normal English, or you can specify the algorithm in graphical manner, or you can specify the algorithm in pseudocode method. Okay, you can specify either in normal understandable language, or you can specify the algorithm in flowchart, or you can specify the algorithm in pseudocode. So these are the three ways to define an algorithm. These are the three ways to define an algorithm. So pseudocode contains set of symbols. So pseudocode contains set of symbols like programming. In a programming, will comment with double slash. In the algorithm also will comment this. And block will represent the method or block. We call it as method or block. Will represented by using the curly braces. Using the curly braces. And the link associated with one to another one will represented with arrow, and assignment operator as already we know that, and logical operators like and or not, and boolean like true and false. So these are the symbols we use for algorithm in the pseudocode method. So there are three, like normal English, like flowchart and pseudocode. So by using these three ways, we can define the algorithm. So in the pseudocode, we'll use these. So like pointer variable and the assignment operator and logical operators and relational operators and Boolean operators and block of the algorithms. So these are the symbols we use. Next, we'll move to actual subject. So performance analysis. Performance analysis. What is the performance analysis? So what is the difference between program and algorithm? The program may be a set of instruction that can be any kind of environment. But algorithm is not like that. Algorithm is a computational procedure. Algorithm is computational procedure. We have to follow some rules and regulation, and we have to perform the evaluation. We have to perform the evaluation. Based on that performance evaluation only, we will say the which algorithm is best. To in order to perform the evaluation, so we use a space complexity and time complexity. We use space complexity and type uh, time complexity. The space complexity is nothing but in terms of memory. The space complexity is nothing but in terms of memory. So what are the amount is required, or what are the amount of memory is required for executing the a particular algorithm, executing the a particular algorithm. So what is the time is taken? What is the time is taken for the algorithm for executing entire algorithm? So based on these two performance evaluation, so we will conclude so which algorithm is best for our requirement, best for our requirement. So so there are three things, or like two things in space complexity: fixed part and variable part, like constant or something. So we'll discuss it later. Okay. But remember one thing: the space complexity is nothing but in amount of memory. The time complexity is nothing but so whatever the time is taken for executing the algorithm. So that is the time complexity and space complexity. And asymptomatic notation. What is asymptomatic notation? So these are nothing but a mathematical notation used to represent the time complexity. in order to represent the time complexity in the mathematical format. In the mathematical expression, we use this asymptomatic notation. Asymptomatic notation. So majorly there are three. So big O notation and omega notation and theta notation. So what are these three? Asymptomatic notation. So these are used to represent a time complexity. These are used to represent a time complexity in the form of mathematical expression. In the form of mathematical expression. So what are they? Three. So big O notation and omega notation and theta notation. So big O notation, omega notation and theta notation. So what are these three? What are these three? So these three are required to represent a time complexity. What is the time complexity? The time is taken for executing the algorithm. So why we need to consider this time complexity? Because based on the performance only we will evaluate every algorithm. So that is the reason why we need to concentrate on the time complexity. The time complexity is in order to represent a mathematical format, we use this three notation. So these three notations are called as asymptomatic notation. So big O notation, omega notation and theta notation. Right. So big O notation, big O notation. This is used to represent upper bound of an algorithm. Big O notation is used to represent upper bound of an algorithm. So big O notation is used to represent upper bound of the algorithm. So let us see an example. Let us see an example in the graph. So see here, f of n is our function. Let us assume f of n is our function and c of g are nothing but the required constant. The required constants are variable, you can see. Variable you can see. So this is upper bound and this is lower bound. This is upper bound and this is lower bound. So big O notation is used to represent upper bound of an algorithm runtime, and omega notation is represent lower bound of algorithm runtime. Lower bound of algorithm runtime. So when you see big O notation and omega notation, only single constant is there. The C for is nothing but constant or variable. C is nothing but constants or variable. When you observe the big O notation and omega notation, only single constants are there. So f of function is about to the constant. About to the constant and in the omega, in the big O notation, the f of n is below the constant. So to the function, we have the constant above. That is means upper bound of runtime, and we have the lower time. So that is nothing but lower bound of our algorithm runtime. So the theta notation is used to represent the running time in between. It is used to represent running time in between upper bound and lower bound. Upper bound and lower bound. So you can see the C1 and C2. C1 and C2. The C1 and C2 are constant and the function is in between the different constant. So in order to represent the differentiation, upper bound and lower bound, will use theta notation. Will use theta notation. So what are these three asymptomatic notation? These are used to represent the time complexity. These are used to represent the time complexity in the mathematical format. In the mathematical format. So ఏమేమి ఉన్నాయి మనకి? First one is what? Big O notation. The second one is what? Omega notation. The third one is what? Theta notation. Omega notation is used to represent upper bound or lower bound? Upper bound of the algorithm runtime. What is this? Runtime. So because we are used to represent the time complexity. So that is the reason why always we should say runtime. Always we should say runtime. upper bound of the algorithm runtime. So omega notation is used to lower bound of the algorithm runtime, and theta notation is used to Now silent. What is this? Silence. What is this? What is this? Is there any? Yes, you are right. This is the law. But there is a meaning for it, and there is a term for it. What is mean? Mean is a mean. Starting point. How can you say this is the starting point? So first of all, what is data type of what here is not a data. Is it? Correct. It is called as return type. What is called as? What is called as in here? Return
Type.
type.
What
What
is
is
main?
main?
Main
Main
is
is
a
a
function
function
name.
name.
Main
Main
is
is
what?
what?
Function
Function
name.
name.
Main is predefined or user defined? Predefined or user defined? గట్టిగా చెప్పండి. Predefined or user defined? వాయిస్ నుంచి వాయిస్ రావట్లేదు. Predefined or user defined? ఎవరు చెప్పారు మీకు? First of all, what is the meaning of define? Defining a function int main. So before main, you should write hash include what? std. What is stdio? Standard input, and that one we know. And what is this? Function, not int main, function declaration. Say yes or no, function declaration. So within this function, we'll use printf. We'll use printf or something, a message, something message. And after this, I'll save this as one.c. I'll save this as one.c. What is the file name here? One.c. What we have written? We have declared one function, and within the function, we are calling the function or not? We are calling the which function? A printf function. We are calling a which function? A printf function. So in order to execute this, we'll go to the program location. We'll go to the program location. The program is available. The program is available in some folder. So here you can see one.c. Here you can observe one.c is available from this location. From this location, I would like to open. From this location, I would like to open command prompt. I would like to open command prompt. Okay. So from the command prompt. So what is the file name? So gcc space one.c. So gcc space one.c. So successfully executed or not? And I'll just executed a.exe. A.exe. So what is the output? Hello is executed or not? Say sir, no. Suppose the same program, I will write like this: void add, open the function and close the function. Open the function and close the function. Within this, I'll declare one variable with I 10. I'll declare one another variable j 50 and int sum equals to I plus j. I would like to printf. What is the format specifier for the integer? D percentile D comma sum. Say sir, no. We have defined some function. We have defined for function. This function contains some of the statement. Forget about what are the statement. These statements are not important to us. So what is important? What happening in the background is important. Okay, right. I have written one function. This function should get execute. This function should get execute. So which function is going to get execute? Main function or add function? First to execute what? Which function? Add or main? Add or main. So if add is executed, what is the output? 60 is the output or not? If main is executed, what is the output? Hello or not? So can we get hello or can we get 60 or can we get both? Both. If I write 3, 3. Okay, we'll check. So what is the command to compile? So gcc space one.c. So gcc space one.c, and after that a.exe. A.exe. So what is the output we have got? Only main. Only from the main. We have not received the output from the add. So add is our own method. Add is our own method. So add is our own method. So but directly in C language, only main method get executed. In C language, only main method get executed. from the main method you should call the add method. You should call the add method. So this is nothing but calling the method. This is nothing but calling the method, and this is nothing but defining the method. This is nothing but defining the method. So do you know difference between defining and calling? What is the difference between defining and calling? Instead of so if you have open the block and close the block, that is nothing but defining the method. So if you have the semicolon, this is nothing but calling the method. Say yes or no? Yes or no? సో ఇప్పుడు ఏం చేస్తున్నాం మనము? సో వీఆర్ కాలింగ్ ది మెథడ్. ఇక్కడ కాల్ చేస్తున్నాం కాబట్టి ఎక్కడ ఎగ్జిక్యూట్ అవుతుంది? సో ఆల్రెడీ డిఫైన్ చేసి ఉంటే మెథడ్ అనేది ఎగ్జిక్యూట్ అవుతుంది. సో నౌ లెట్స్ అబ్జర్వ్ ది అవుట్పుట్. సో జీసీసీ స్పేస్ 1.c and a.exe. So what is the output we got? So from the main method we got the output, as well as from the add method also we got the output. Hello and 60. So now tell me, so what is the difference between so definition and declaration? What is the difference between definition and calling? Suppose let us assume I'll delete this add method. I'll delete this add method. I'll just call without any definition. Is it possible? Is it possible? Can we call without a definition? Without a function declaration? So what happened if I call like this? So it will give some error. Implicit declaration function add. So calling the function is not possible or not? Yes or no? So without a declaration or without a definition, so we cannot call the function. We cannot call the function. So now come to the main method. So you are saying that main is a predefined method. I am saying that main is user defined method. Why? Because main method execute first. Say yes or no? Main method execute first. Why? Because they call only main method. Got the clarity? They call only main method. They will not call any other method. They will call only main method. If the main method is available, it will get executed. Why? Because they internally call only main method without calling. Without calling, so there is no method getting executed. Without calling, there is no method get executed. That means the C people, so internally they calls only main method. They will not call any other method, but main method should be defined by the user. Yes or no? Main method should be defined by the user. How can you define? Suppose let us assume instead of main method, I'll just write add method. Is it possible to execute this? Is it possible to execute this? No. Why? Because we have to call the method. From where we need to call? Because the C people directly call the main method. The C people directly call the main method. So that is the reason why main method should be defined. Main method should be defined before calling the method or not. So this is our own method, and this is also our own method, and this is also our own method. So we are defining the main method as well as we are defining the add method. Say yes or no? So these two methods are defined by the user or C language. ఎవరు డిఫైన్ చేస్తున్నారు? మనం డిఫైన్ చేస్తున్నామా, సి లాంగ్వేజ్ వాళ్ళు డిఫైన్ చేస్తున్నారా? మనమే డిఫైన్ చేస్తున్నాం. సో సి లాంగ్వేజ్, in C language, main method is a user defined or free defined? User defined, but they call only main method. They will call only main method. So that is the reason why main method get executed first. Main method get executed first. From the main method you can call any other methods. So sip. What is this? Don't say printf. It is calling our definition. Calling our definition. Calling. Scanf. Calling our definition. Get character. Calling our definition. CLR, SCR, calling or definition. So most of the functions are nothing but calling. STR, CMP, calling only or not only this. System dot out dot printf, calling only or not. What is the function name? What is the function name? Printf. Yes or no? So this is nothing but Java. Okay. Next, def add. What is def? Shortcut form. Definition. What is def? Definition of addition. Definition of addition. This is nothing but declaration. This is nothing but declaration. Add, calling. So this is in Python. This is in Python. Okay. Everywhere same. Everywhere is same. Only the concept is you should know what is the definition and you should know what is the calling. So do you got the idea about definition and calling or not? Say yes or no. So for everyone there is own language. Okay. So Kakinadaki own language unda. ఉందా? లేదు కదా. ఈస్ట్ గోదావరికి ఓన్ లాంగ్వేజ్ ఉందా? దెర్ ఇస్ అ సపరేట్ లాంగ్వేజ్. సేస్ ఆర్ నో? సో తెలంగాణలో సపరేట్ లాంగ్వేజ్ ఉందా? సేస్ ఆర్ నో? ఫర్ మహారాష్ట్ర దెర్ ఇస్ అ సపరేట్. ఫర్ తమిళనాడు దెర్ ఇస్ అ సపరేట్ లాంగ్వేజ్. ఫర్ కంప్యూటర్ సైన్స్ ఇంజనీర్ ఆల్సో దెర్ ఇస్ అ వన్ లాంగ్వేజ్. For computer science engineers also there is one language, that is nothing but programming language. Not C, not Java, not C++, not Python. Okay, the programming language is different, programming technologies are different. If you know the language you can learn any technology. If you don't know the language, so you don't learn any technology. Simple. If you know the definition, you can understand any language. If you know the method calling, you can understand any language. If you read int main, so now tell me, what is this? Int main. Int main. This is nothing but function declaration. What is this? Printf. Function call. This is called as computer science engineering language. This is called as computer science engineering student language. Now tell me, so public static void main. Open the method and close the method. What is this? Declaration and function do valid. Declaration. So JavaScript, PHP, and this is Java, and this is Java, and this is PHP, and definition and function. This is Python. This is Python. So concept is same for all the languages. Concept is same for all the languages. You should concentrate what is definition and what is call. We'll discuss just 2 minutes. right? Right? So observe here, you got the idea about function definition and function calling, right? Say yes or no? So which is a function calling and which is function declaration? Okay? So just to see here, just observe here. Just observe here. What is this? Structure. The structure name is node. The structure name is node. It contains how many variables? 1, 2, 3, and 4. So what are these variable and what are these variable? So these are like normal variable and these are pointer variable. And what is this? Don't say height. What is this? There is a return type, there is a function name, open the function and this is called as function. What is the function name? Height. And what is this? Max function definition. Height function definition, max function definition, and new node function definition, as well as right rotate, as well as left left rotate, as well as get balance, as well as insert, and as well as in order, as well as main. These are all what? Function declaration. These are all what? Function declaration from the main method. From the main method. So what we are calling? We are calling the insert. We are calling the insert. How many times? For 10, for 20, for 30, for 40, for 50, for 25. We are calling the which function? Insert function. Which function? Insert function. So insert function internally calls which function? Get balance. Internal function which calls get balance, as well as right rotate, as well as left rotate. So do you observe the semicolon and open the? Say sir, no. Do you remember and do you recognize, right, what is definition and what is method calling and what is function declaration? So simple observe here. It is what? Function definition or function declaration? Function declaration. Why? Because it contains open the method and close the method. And what is the max here? Max is also a function definition. And new node is also a function definition. Right rotate is also a function definition. We'll come to this. What is right rotate? What is left rotate? What is maximum? What is height? What is the required for structure? Everything we'll discuss it. But okay, so నాకేం చెప్పారంటే, సో our students are intelligent, our students knows everything, so just discuss the practical. బట్ ఇక్కడికి వచ్చిన తర్వాత చూస్తే డజంట్ నో ఎనీథింగ్ అబౌట్ సో ఫంక్షన్ డిక్లరేషన్ అండ్ ఫంక్షన్ కాల్. సో విత్ దిస్ నాలెడ్జ్ ఐ వుడ్ లైక్ టు డిస్కస్ అడ్వాన్స్డ్ డేటా స్ట్రక్చర్. నో రైట్, come to this. Don't worry, I will explain clear. Okay, tell me, get balance is a function declaration or function calling? Very important. Function declaration or function calling? Function ఎలా చెప్తున్నారు? Because it has contains the block. Open the function and what is this? Function. Why? Because we have the got the clarity or not? So next, left to rotate function. What is this arrow? Pointer or not? Sir, no. Pointer or not? So when it is a structure to a pointer, the structure variable must and should be accessed with arrow. So other symbols like key and height. Okay, so we'll discuss it. Then what is recursive? What is recursive? The function call internally itself is called as recursive. So what is recursive means exactly? Suppose there is a function called as something Fibonacci series. There is a function called as function name is Fibonacci series. So this is called as function definition or function declaration. Already we know that. Outside the function, generally we call this method. So generally, right? So right. So generally, outside the function, we call the method. Suppose within the definition only, within the definition only, we call the same function. Within the definition, if we call the same function, is called as recursive function. That means this function call itself, this function call itself is called as recursive function. ఓకే సో సేమ్ ఫంక్షన్ మళ్ళీ అదే ఫంక్షన్ని కాల్ చేసుకుంటే మనం ఏమంటాము రికర్సివ్ ఫంక్షన్ అంటాము. సో జనరల్లీ అవుట్ సైడ్ ఆఫ్ ది డెఫినేషన్ మనం ఫంక్షన్ కాల్ చేస్తాము, బట్ మెథడ్లోనే బ్లాక్లోనే మళ్ళీ కాల్ చేస్తే దాన్ని ఏమంటాము అంటే రికర్సివ్ ఫంక్షన్ అంటాం. ఏమంటాం రికర్సివ్ ఫంక్షన్. సో ద ఫంక్షన్ డిక్లరేషన్, ద ఫంక్షన్ కాలింగ్ అండ్ రికర్సివ్ ఫంక్షన్స్ ఆర్ ఇంపార్టెంట్ టు అండర్స్టాండ్ ది data structures concept. Okay, so now let us move to the next topic. Let us move to the next topic. Okay, simple. So advanced data structures are completely depends on the binary tree and binary search tree. So advanced concept completely depends on the binary tree or binary. Right. So observe here. So binary tree is one of the data structure. Binary tree is one of the data structure. Okay. So don't worry anything about. So don't bother anything about it. So we'll discuss it later. So for today's sake, I will explain
whatever the required time requires, I will explain clearly. Okay, so if time permits, so we'll discuss from the scratch. Okay, so what is function and how we write a C language? So what is the things in order to understand the data structure? Everything we need to plan and we need to discuss it. Okay, so for today's classic, you need to understand whatever we are going to discuss now, right? So binary tree. So just assume. So forget about all the things. Just assume like general. So in general, I'll explain. So binary tree is a data structure. Binary tree is a data structure. Okay. So what is the use of the data structure? To arrange the data in a particular manner. To arrange the data in a particular manner. So binary tree is one of the data structure, and the binary tree contains what? Node. The binary tree contains what? Nodes. So nodes are nothing but normal like tree. Okay, normal like tree. Okay, can have maximum of 2 children, but there is no need to maintain the order of the nodes. There is no need to maintain the order of the nodes. What is the meaning of the order of the nodes? Suppose. So descending order and ascending order. Descending and ascending. So these kind of orders we no need to follow for the binary tree data structure. Okay. So binary tree is a data structure that contain at least two nodes. That at least contain two nodes. So let us an example. Let us take an example. So binary tree is a data structure that contains that contains, so at least two nodes. So such as let us take an example. So 60 is the element. 60 is the element, and I can write 40 here, I can write 50 here, or I can write 70. Okay, so this is the tree. This is the tree. So this is the tree. So which contains three elements totally. Which contains three elements totally. We call this 60 as root node. We call this 60 as root node. We call this 60 as root node. And we call this 40 as left node. We call this 40 as left node. And we call this 70 as right node. Okay. So binary tree is a data structure. Binary tree is a data structure. Node. Sir. Right. So let us assume binary tree is a data structure that every node can have maximum of two children. Okay. So binary tree is a nothing but root node. This contain two children. That is a left node and right node. That is a left node and right node. So in this binary tree, the elements are arranged in the order they arrived at the top up, top to bottom, top to bottom, and left to right, top to bottom and left to right. So no need to maintain the order. So any elements, they can come from top to bottom, left to right, top to bottom and left to right. So if I want to insert new element, if I want to insert new element, suppose let us assume I would like to insert 50.
I would like to insert 50. The 50 comes under what? Top to bottom and left to right. So first always left, then right. So here you can insert 50. Next, top to bottom.
Okay.
Right. So what we are discussing here. So we are discussing a binary tree, so which is most important. So every node can have maximum of two childrens, but there is no need to maintain the order. But there is no need to maintain the order. And in the binary tree, elements are arranged from top to bottom and left to right. So if elements are inserted in the top level, then it comes to bottom. If the bottom is inserted, then again it goes to the left. If the left is inserted, it comes to right. Is it clear? So all the elements are inserted from top to bottom and left to right. So first priority top. So if top already occupied, so it will go to the bottom. If the bottom is already occupied, it comes to the left. If the left is occupied, comes to right. So that is the exact meaning of top to bottom and left to right and left to right. So what is a binary tree? So binary tree is a one of the data structure to manage the or to manage the data. So what is the meaning of data? What is the meaning of manage? You can search, you can insert, you can delete. You can insert and you can delete. So these are nothing but managing the data by using the binary tree. Managing the data by using the binary tree. So these are nothing but big O of n. That is nothing but big O notation. Big O notation is nothing but asymptomatic notation of the first notation. That is nothing but to measure the upper bound or lower bound. Upper bound of the time runtime. So runtime of the algorithm. And for insert operation, what is the time complexity? So big O notation of 1. And the deletion operation, what is the time complexity? Big O notation of n. So n number of elements we can search, and one element we can insert based on the priority, and the delete we can delete any number of search. And so binary tree is unordered. Binary tree is unordered tree. That means there is no order for the binary tree data structure. In order to order, in order to order the elements in the binary tree, we introduce a new concept called as binary search tree. Binary search tree. So binary search tree is the enhanced version of the binary tree. Binary search tree is a enhanced version of the binary tree. So this is useful. This is useful. Focus on search operation. This is useful. So search operation and can be defined as follows. Can be defined as follows. So binary tree is the advanced version of the binary search tree is the advanced version of the binary tree, and this is very useful while searching the element into the binary tree or binary search. Then what is the major difference? What is the major difference between binary tree and binary search? Binary tree and binary search. So in the binary search tree, in the binary search tree, every node contains values in the its left subtree and larger values in its right subtree. So what is binary tree? Binary tree is unordered data structure. There is no need to maintain the order in the binary tree. So directly you can insert, directly you can delete, directly you can update. So without irrespective of the order. So but what we have to follow the order, top to bottom, left to right. So that is the only thing we need to follow in the binary tree. Then it comes to the binary search tree. When it comes to the binary search tree, so all the left nodes, there is root node, there is left node, there is right node. All the left node must and should be smaller than the root node. Smaller than the root node. And all the nodes from the right side, all the nodes from the right side should be greater than to the root node. Should be greater than to the root node. So got the clarity. So what is the binary search tree? Binary search tree root must be so one, and that root we have left subtree, we have right subtree. We have left subtree and we have right subtree. So all the left subtree contains smaller values to the root node, and all the right tree sub elements will be larger than the root node. Larger than the root node. Okay, the node must be one element. To that element, all the smaller values will place inside the left side, or the larger values will place inside the right side. So if you arrange like this, so this is called as binary search tree. Binary search tree. So all the left tree are smaller to root node, all the right subtree are larger to the root node. We'll take one example here. So you can observe the 25 is the root node. The 25 is the root node. To the 25, so 20, 10, 22, 5, 12, 1, 8, 15 are the left subtree, or the left subtree. And 36, 30, 40, 28. Okay, right. So when first element is 43. First element is 43. First element is 43. And the, what is the second element? 10. So 10 is smaller than 43 or not? So this should be left side or right side? So left side, 43 to 10. So what is the next element? 79. So 79 is larger than 43 or not? That means left or right. So right side. So forget about this level 1. So level 1 is completed. So next level. 93, sorry, 90 is larger than 79 or smaller than 79. So larger means left side or right side? Right side of the 79. So next element. What is the next element? 12. So 12 is larger than 10 or smaller than 10. So larger means right side or not? Say sir, no. What is the next element? 54. 54 is less than 79 or larger than 79? Less than means left or right. And what is the next element? 11. So 11 is larger than 12 or smaller than 12? So smaller means left or right? So left means 12 to 11. 12 to 11. And what is the last element? So last second element? 9. So 9 is a smaller 2. 9 is a smaller 2. 10 or larger than 10? Smaller than 10. That means 10 to 9. So meaning is the nearest value, the nearest value. So based on the nearest value, so we will insert the element. So read the next element. If it is lesser than the root node element, root node element, so we will take one element one by one. We will take element one by one. So we will check whether root is exist or not, which is near to that element. So if it is near to that element, we will place. So let us take an example. So 10 root is there and we are inserting it 9. So which is very near to 10, right? To the 10 root, we will place either left or right. Either left or right. So 9 is smaller than 10. That is the reason why I place it in left side. So this is called as binary search creation. This is called as binary search creation. What is a binary search tree? It is ordered or unordered tree? What is a binary tree? Unordered tree. So what is the difference between binary tree and binary search tree? Binary tree is not ordered. It follow only one thing called as top to bottom, left to right. But binary search tree is a ordered tree. So root element must be unique and all the left node should be smaller than the root node and the larger values from the right side. So ఎలా ఇన్సర్ట్ చేస్తాం మనము బైనరీ సెర్చ్ ట్రీలో? It's all based on the nearest value of the root. It's all based on the nearest value of the root. So ఈ ఎగ్జాంపుల్ రాసుకుంటారా? ఈ ఎగ్జాంపుల్ రాసుకుంటారా? సో ఫాస్ట్గా రాసుకోండి. So example 1, binary search tree. So very important. So example 1, create the binary search using the following elements. Create the binary search tree using the following elements. The elements are 43, 10, 79, completed, 90, 12, 54, 11, 9, 50. So this is only theoretical explanation how the tree look like. Okay, we'll come to the program. Write these 3 lines fast.
12 to 1. Only 1 to 1 to 4. So 12 to 12:30 we'll take lunch. Then 12:30 to 1:30. Then 1:30 to 4. Because only single program. ఒకసారి రెడీ 12:30 to 1 1:30. Okay. Completed. Right. Completed. Direct. Direct step. That is the reason why you forget everything in the examination. ఎవ్వరు రాయట్లే రాసావా చేయండి మొత్తం ఓ రాయట్లే అమ్మాయి రాసా theory you want, right? So what is the difference between binary tree and binary search tree? So binary tree is unordered tree. So it is a data structure which is not follow the order, and it follow only one thing called as top to bottom and left to right. So whereas a binary search tree is ordered, it's all based on the left and right. Left and right. All the left node elements are smaller than the root node. All the right node elements should be larger than the root node. So this is called as binary search tree. This is called as binary search tree. So we can add, we can delete, and we can search. So we'll discuss it later. So now I'll introduce the concept called as AVL trees. AVL tree. So AVL tree is also AVL tree is also a binary search tree. AVL tree is also a binary search tree, but it is a high balanced binary search tree. It is a high balanced binary search tree. AVL is nothing but it is also a binary search tree. AVL tree is also a nothing but binary search tree, and it is called as height balanced tree. It is called as height balanced tree. Height balanced tree. So what is the balance? The balance is every node must and should be -1, 0 or +1. The balance of the tree must and should be -1, 0 or +1. So only these three balanced factors
Only these balanced factors. So what are the balanced factors? Either -1, 0 or +1. Only these three. Any other things are not called as imbalanced or unbalanced tree. Okay, so what is the tree name? AVL tree. What is the tree name? AVL tree. AVS is also a binary search tree, but every binary search is not a AVL tree. So binary search tree with height balanced, binary search tree with height balanced. That height must and should be, that height must and should be -1, 0 or +1. -1, 0 or +1. So this is all under balance factor. This is all under balance factor. So every node maintains an extra information called as, every node maintains an extra information called as balance factor. Every node in the binary search maintain one balance factor. That balance factor must and should be -1 or 0 or +1. -1, 0 or +1. So if any tree maintain this balance factor, if any binary search tree maintain this balance factor, so that tree will become AVL tree. That tree become AVL tree. So what is the balance factor? The balance factor is nothing but, the balance factor is nothing but height of left subtree minus height of right subtree. What is the balance factor? So balance factor is nothing but height of left subtree minus height of right subtree. So balance factor is nothing but height of left subtree minus height of right subtree. So this balance factor must and should be only 3. Must and should be only 3. So -1, 0 or +1. -1, 0 or +1. ఒకవేళ -1, 0 or +1 లేకుంటే దాన్ని ఏమంటాము? దాన్ని ఏమంటాము? ఇంబ్యాలెన్స్డ్ ఏవియల్ ట్రీ. ఒకవేళ -1 + 0 + 1 ఉంటే ఏమంటాము? బ్యాలెన్స్డ్ ట్రీ. దట్ ఈస్ నథింగ్ బట్ ఏవిఎల్ ట్రీ. That is nothing but AVL tree. So every node must carry an extra information. Every node must carry an extra information called as a balance factor. How can you measure this balance factor? The balance factor can be measured using height of left subtree minus height of right subtree. What is the meaning of height here? What is the meaning of height here? The height is nothing but any link. The height is nothing but any link to the node. Any link to the node. So you can observe here. You can observe here. So 25 is the root node. 25 is the root node. To this node, there is a left node and there is a right node. There is a left node and there is a right node. So what is the left node? 20. And what is the right node? 36. So there is a left node and there is a right node. So what is the balance factor formula? The balance factor formula is nothing but height of left subtree minus height of right subtree. So height of left subtree, let us take, already element is available. That is the reason why 1. And what is the right element is available? That is also 1. So 1 minus 1. What is the output? So this balance factor of this node is 0. Right? Next. So you need to come from so bottom to top. So there is no 1 minus 0 minus 0, 0 minus 0, 0 minus 0. Yes or no? And 10. For 10 there is no left subtree. Only right subtree is available. So what is the balance factor formula? Left subtree minus right subtree. So what is the left? 0. Minus right subtree is 1. 0 minus 1 is nothing but minus 1. Yes or no? So here, so the balance factor must and should be -1 or +1 or 0. -1, +1 or 0. So then only we can call it as AVL tree. Then only we can call it as AVL tree. What is an AVL tree? AVL tree is a AVL tree is a height balanced date binary search tree. Height balanced binary search tree. What is a binary search tree? The left node element should be lesser than the root node, and right node element should be larger than the root node. Then only we can call it as binary search tree. Then what is AVL tree? AVL tree must contains an extra information called as balance factor. The balance factor can be formulated, can be calculated by using a one formula called as height of left subtree minus height of right subtree. So it's all based on left subtree minus right subtree. So balance factor must and should be -1, 0 or +1. So then only we can say that is a balanced tree. If not -1, if not 0, if not +1, so this is called as imbalanced tree. So if not +1, if not 0 or something, so if not this 3, that is called as imbalanced tree. So what happens if it is imbalanced tree? So let us take an example. Let us take an example. So insert 1, 2 and 3. Insert 1 and 2, 3. So 1, 2, 3. So what is the left to the 3 node? 0. What is the right node of 3? 0. 0 minus 0, 0. And what is the left node? 0. And what is the right node? 1. 0 minus 1, what is the factor? -1. So 2 to 3 is balanced 3. 2 to 3 is a balanced tree. And come to the 1. What is the left node to the 1? 0. What is the right node to the 1? -1. So 0, 0, -1 and -1. Yes or no? -1 and -1 is what? -2. So -2 is not considerable. It's not considerable. So either should be balance factor should be 1, 0 or -1. If it is -2, if it is -2, so it is called as imbalanced tree. It is called as imbalanced tree. In order to make the balanced tree, in order to make the balanced tree, so we use some rotations. We use some rotation. So those rotations are called as AVL tree rotation. AVL tree rotation. So these are two types. These are two types. So single rotation and double rotation. Very, very important. Very, very important. So in order to convert imbalanced tree to balanced tree, we'll use rotations. We'll use rotations. There are two types of rotation. So single rotation and double rotation. So single rotation and double rotation. In the single rotation, we have again two, LL rotation and RR rotation. LL rotation and RR rotation. So LLL means left rotation, RR means right rotation. RR means right rotation. RR means right rotation. LR rotation, left to right. So we have to do the left first and right next. And right left. So we have to right first and left second. So that is the reason why. So these are called as double rotation. So in those cases we use only one rotation. So either left or either right. Either left or either right. Okay, so basically there are four rotations. These four rotations are categorized into two rotations. So single and double. In the single, LL rotation and RR rotation. LL rotation is nothing but left rotation and RR rotation is nothing but right rotation. And comes to double rotation. The double rotation we have two, LR rotation and RL rotation. Left and right rotation, right and left rotation. So what are the use of these rotations? What is the use of this rotation? So while constructing the AVL tree or while searching the AVL tree or while inserting the AVL tree, you may get imbalanced tree. So AVL tree must be height balanced tree. So height must be 0, 1 or -1. So if you get any other height, you have to balance a tree. In order to balance a tree, we use this rotation. We use this rotation. How many rotations are there? 4 rotation, LL rotation, RR rotation, LR rotation and RL rotation. So now observe. Now observe here. So this is balanced tree and this is imbalanced tree. Got the point? Got the point? So there are two. So there is -2, it is imbalanced. According to the AVL property, according to the AVL property and definition, -2 is imbalanced. So balance should be -1, 0 or 1. So in order to order the tree from the imbalance to balance, so we use the rotation. We use the rotation. So what is the binary search tree? Left node should be smaller and right node should be larger. So what should be the root node? The root node will become 2. The 2 will become root node. The 2 will become root node. Then 1 will become what? Left node, and 3 will become what? Right node. So this is called as from right to will move to the left. So this is called as LL. This is called as LL rotation. We move the tree to left. We'll move the tree to left. So this is called as LL rotation. So when you rotate to the left, so 2 will become the root and 1 will become the left and 3 will become the 3. So why only one left? All the elements, left element should be small and right element should be capital. So larger than the root node or not. So that is the reason why 2 is the root node and 1 is the left node and 3 is the right node. So this is a binary tree, and when you count balance factor, so this is 0 and this is 0 and 1 minus 1 is also a 0. So either 0, 1 or -1 is called as AVL tree. Is called as AVL tree. How can you find this balance factor? What is the formula? Height of the left subtree minus height of the right subtree. So single right rotation. So same elements, same element. So here we introduce the left one. Here we introduce the right one. So 1, 2, 3. 1, 2, 3. So what is the balance factor? 0 and 0. What is the balance factor? 1 and 0. 1 is there. 1 is already there. So next, what is the balance factor? 1 and 0. 1 and 0. 1 plus 1, 2. 1 plus 1, 2. So 2 is imbalanced. So 2 is imbalanced. So that is the reason why we move this left tree to right. So we use RR rotation. We'll use what? RR rotation. So RR rotation means, again, what is the root node? Again, what is the root node? According to the binary search tree, according to the binary search tree, all the left elements should be smaller and all the right elements should be capital. So that is the reason why 2 will become root node again and 1 and 3. 1 and 3. So this is called as RR notation. We'll move to the right. We'll move to the entire tree to the right, entire one element. So we'll move to the 3 to the right and 1 to the same location. So this is called as RR rotation. This is called as RR rotation. Then what is the left right rotation? What is the left right rotation? So observe here, 3, 1, 2. So 3, 1, 2. So 2 balance factor is 0 and 1 balance factor is -1. So 1, 0, -1. 0 minus 1 is -1. And after that, what is the balance factor for 3? So already 1 is there and 0 is there. 1 plus 1, 2. Yes or no? So 2 is imbalanced. So what we need to do is the root node should be 2. The root node should be 2 and one node should be left and 3 nodes should be right. So for that, for first, what we need to do is we need to form the LL rotation first. We need to form the LL rotation first. Then we need to form the LR rotation. We need to form the LR rotation. So first we'll construct these two LL rotation that will become, so we will use 1 to the leaf node to the tree and 2 is the middle and 3 is the top and 3 is the top. And after that, first we have written the LR rotation. So left and right, left and right. So left and right. So left, so the right will become left and the next one will do the right. So don't be confused. Don't be confused. Only four things are available. So LL rotation, RR rotation, LR rotation, and RL rotation. So we'll convert this three into left first. We'll construct this tree into left first. The left is completed. Again this left into right. Again this left into right. So that is called as LR rotation. That is called as LR rotation. What is the right and left? What is the right and left? We'll construct right tree first, then we'll convert it into left, then we'll convert it into left. So this is called as RL rotation. This is called as RL rotation. So now tell me, what is an AVL tree? AVL tree is a binary search tree. Every binary search tree is a AVL tree? No. So, by AVL tree contains height balanced tree. AVL tree contains what? Height balanced tree. So, what is the height? The height is nothing but height of the left subtree minus height of the right subtree. So the balance factor should be 3 or 4. 3. What are they? 0, minus 1 or plus 1. Except this balance factor, any balance factor occurs. So what will become? The tree will become imbalanced tree. The tree will become imbalanced tree. Then what we need to do? We need to do the rotation. We need to do the rotation. How many rotations are there? 4. So that LL rotation, RR rotation, LR rotation, RL rotation. So it's all based on the insert into the tree. It's all based on the elements into the tree. So according to the requirement, we will perform LL rotation, we will perform RR rotation, we will perform LR rotation, we will perform RR rotation. So all these rotations are used to convert imbalanced tree to balanced tree. We'll convert imbalanced tree to balanced tree. What is the meaning of LL rotation? We'll move to the tree to left. What is the meaning of RR rotation? We'll move to the tree element node to right. What is the meaning of LR? First left, then second right. So what is RL? First right, second left. So LR and RR considered as double rotation and LL and RR considered as single rotation. So is this clear? Is this clear as of now? So what is the formula of balance factor? Height of the left subtree minus height of the right subtree. Height of the left subtree minus height of the right sub. What is a binary search tree? Binary search tree is a order or unordered? Order ఎలా ఉంటుంది? All the left element should be smaller than the root node and all the elements from the right side should be larger than the root node. ఇది ఎలా ఇన్సర్ట్ చేస్తాం మనము? It's all based on the nearest node. It's all based on the nearest node. ఇప్పుడు 10 and 9 ఉంది. ఓకే, 10 ఆల్రెడీ ఇన్సర్ట్ అయ్యింది, 9 ఇన్సర్ట్ చేయాలి మనం. ఎక్కడ ఇన్సర్ట్ చేస్తాము? 10 దగ్గర ఇన్సర్ట్ చేస్తాం. ఇక్కడ ఇన్సర్ట్ చేస్తాము 10 దగ్గర ఇన్సర్ట్ 20 ఆల్రెడీ ఈస్ అవైలబుల్. నెక్స్ట్ 21 ఇన్సర్ట్ చేయాలి. ఎక్కడ ఇన్సర్ట్ చేస్తాము 20 నోట్ దగ్గర ఇన్సర్ట్ చేస్తాం. రైటా లెఫ్టా? 21 is greater than 20 means right or left? Right. So is this clear? So this is theoretical part. So మీకు అర్థమైపోయింది కదా, what is a binary tree, what is a binary search tree, what is a AVL tree. AVL tree అంటే ఏం చెప్తారు? It is a height balanced binary search tree. Can I say like that? Height balanced binary search tree is nothing but AVL tree. AVL tree. So మనకి ఎన్ని రొటేషన్స్ ఉన్నాయి? మనకి 4. ఈ రొటేషన్స్ అన్ని దేనికి యూజ్ చేస్తాము? టు కన్వర్ట్ ఇంబ్యాలెన్స్డ్ ట్రీ టు, సో బ్యాలెన్స్ ఫ్యాక్టర్ షుడ్ బి 1, 0 ఆర్, సో వీటి నుండి ఏమంటాం? ఏ ట్రీ అంటాము? బైనరీ సెర్చ్ ట్రీ అంటామా, ఏవిఎల్ ట్రీ అంటాము? సో ఏవిఎల్ ట్రీ ఈజ్ ఇన్వెంటెడ్ బై 3 people. AVL tree is invented by 3 people. So that is the reason why their first letter A is 1 man and V is 1 man and L is 1 man. Okay. So that is the reason why AVL tree. So AVL tree is useful for searching a particular element. Best useful for searching the element. So but are also we can do the insertion and deletion. We can also do the insertion and deletion. So we will check how to insert and how to delete. But this is the theoretical part. For this we have the program here. For this we have the program here. Now you can understand the code. Now you can understand the code. Simple. What is this? Node. What is this? What is this? What is height? Height of the left subtree minus, yes or no? This is height is nothing but balance factor. Height is useful for balance factor. What is left and what is right? What is left and what is right? Left subtree and right subtree. What is this? What is this? Maximum. So we need to find out binary search tree or not. So maximum and minimum. Okay. Next. Right. Right rotate means how many are there? 4 or 5? 4 or 5? What are they? LL rotation, RR rotation, LR rotation and, so what is right rotation? RR, what is this? Left, what is this? What is the use of get balance? Height factor or, sir, no balance factor. Next, insert or not? So now tell me here. In order, so what are the elements? 10, 20, 30, 40, 50 and by taking these values, we will take one simple program to construct AVL tree. By using this AVL tree, we will find out the height. We will find out the height. Based on the height, we will balance the tree by using right rotate and by using left rotate. Is this clear? And for getting the each and every time balance, we'll use this method called as get balance. For insert element, we'll use the insert function. Now you got the understand the code or not? Say yes or no. At least words అనేది మీకు తెలుస్తున్నాయా? Say yes or no. అర్థమవుతుందా? సో ఇంకా బిగినింగ్ క్లాసెస్ మీకు అవసరం. ఓకే. సో వాట్ ఈజ్ స్ట్రక్చర్ అండ్ వాట్ ఈజ్ నోడ్ అండ్ వాట్ ఈజ్ పాయింటర్. సో వెన్ యూ గెట్ ఫుల్ క్లారిటీ ఇన్ ది పాయింటర్ అండ్ స్ట్రక్చర్ అండ్ minimum basics of programming, then you will get all this code. Okay. So as of now, just observe. Just observe. Okay. So our motto is we need to construct an AVL tree. We need to construct an AVL tree for insert and for insert. So see here. So you can see 1 minus 1 and 0. Okay. So what are these? What are these? What is the balance factor formula? Height of the left subtree minus clear. Clear. So this is programming. So you need to understand the concept and you need to write the program. Okay. For simple I am executing this program. Okay. So CLS GCC space. So a dot exe, the total travels of t is nothing but 10, 20, 25, 30 and 40 and 50. Okay. So make a note of these elements. Make a note of this element. Construct AVL tree. Construct AVL tree by using this element. You have to construct a tree. Yes or no? Like this. 10 to 50, middle 25, 10 to 50, middle 25. You need to construct a AVL tree like this. ఆ ఎలిమెంట్స్తో ఇలా ఏవిఎల్ ట్రీ అనేది మీరు కన్స్ట్రక్ట్ చేయాలి. ఎవ్రీ నోడ్ బ్యాలెన్స్ ఫ్యాక్టర్ షుడ్ బి 0 ఆర్ 1 ఆర్ -1. ఓకే. And all the left tree nodes must and should be smaller than root node. All the right node elements should be larger than the root node. So ఇలా కన్స్ట్రక్ట్ చేయాలి. అండ్ బ్యాలెన్స్ ఫ్యాక్టర్ కూడా 1 ఆర్ -1 ఆర్ 0 ఉండాలి. ఓకే. సో కన్స్ట్రక్ట్ చేస్తారా? సో ఫార్ములా చెప్పండి. బ్యాలెన్స్ ఫ్యాక్టర్కి హైట్ ఆఫ్ ది లెఫ్ట్ సబ్ ట్రీ మైనస్ హైట్ ఆఫ్ ది రైట్ సబ్ ట్రీ. ఓకే. సో ఇంబ్యాలెన్స్ ఉంటే మనం ఏం చేస్తాము? ఏవిఎల్ ట్రీ అనేది ఇంబ్యాలెన్స్ ఉంటే ఏం చేస్తాము? విల్ డూ ది రొటేషన్. ఎన్ని రొటేషన్స్ ఉన్నాయి మనకి? ఎల్ఎల్ రొటేషన్, ఆర్ఆర్ రొటేషన్, ఎల్ఆర్ రొటేషన్ అండ్ LL means left rotation, RR means right rotation, LR means left and right, RL means right and. So LR and RL nothing but double rotation. LL and RL are single rotation. Got the clarity? So take the lunch and come back. We'll discuss.